Hello, welcome to the Joy of Automation. My good friend Mike Conley started a while ago something called the Joy of Coding, and I'm going to follow suit and show a little bit on how we automate things around in Mozilla. My name is Armin Zambrano. I work for the productivity engineering team, or engineering productivity team, from the platform operations umbrella inside of Mozilla. We used to be called the A team. Now we're called that. And what we do mainly is write code in Python. That's one of the main programming languages we use, and that's the one that I use the most. At Mozilla, we help automate all of the Firefox builds, Firefox tests, things around continuous integration and showing jobs. There's also Bugzilla, and there are various automation teams or people. There are various teams that do a lot of automation. In this case, I'm going to be talking about a bug that I'm going to be working on. I went away for some weeks, and when I came back, this bug was around. I was aware a little bit of the bug before I left, but there was some discussion on trying to figure out what was going on. Now, what I'll tell you about this episode and many to come is that it's completely unscripted. It could take 15 minutes to fix. It could take 2 hours. I might do it in 2 parts because I'll need to take a break. And I'm going to make mistakes, many. And sometimes you will see me do things the wrong way, and feel free to let me know of better ways of doing it or better tools to do it. I'm a lot about big picture, but sometimes I'm very easily can miss details. In any case, I'm gonna jump straight into the project. There's a project called Pulse Actions, and in Pulse Actions, what we have is before I jump into Pulse Actions, I'm gonna show what the actual developers can see. So we have a tool called Tree Herder, and Tree Herder allows you to see jobs scheduled on the push on your code and the code that you push. And you will get builds, you will get tests, and there is a specific repository called the try server. And the try server allows you to schedule jobs according to something called the try syntax. So on your latest push, you can specify which builds you want. D stands for debug, O for optimize, which platforms you want if you don't want all of them, or which test suites you want. Now, if you use the wrong try syntax, you could schedule the wrong things, and you may want to add it. And until recently, there wasn't the possibility of adding new jobs to a push. You would actually have to push again the same changes with a different try syntax to allow you to schedule exactly what you wanted. Now, let's see how this looks for the developer. If I click on add new jobs, it's going to talk to an API, and it's going to be able to tell you that all of these jobs could have been scheduled. So if I select this, and this, and this, and this, I could go ahead and click trigger new jobs, which I'm not going to do. And trigger new jobs, what it will do, it will actually send a pulse message over a wire, over the pulse protocol. It's a publisher and consumer type of system. So tree herder will send some sort of tree herder action, a message, a JSON message, that Pulse will put it into the queue that my tool Pulse Actions consumes from, and it will see the request from the developer, and the developer's request will be fulfilled by Pulse Actions, and it will use a tool called MozCI that allows you to talk to the 2 different continuous integration systems there are. Currently, we only support BuildBot, which we do schedule jobs through self-serve build API. In the near future, we'll have task cluster support. If you excuse me for a second, I'm just gonna mention that I am on a recording. Hi man. I'm doing a live recording. It's not live. Catch up with you later. And I wonder if anybody else. Okay. So nothing urgent. The world can keep on going a little longer without me jumping into it. Now, where was I? So we have this system that sends a pulse message, we consume it, and we schedule jobs accordingly. Now the system is something that I inherited. I had an intern work with me and got it done. Unfortunately, since the project got completed and went live, there's been issues here and there. Some of them were addressed, they were patched. But there are various problems. One of them is we don't show results to the developer. The developer won't know if anything got scheduled properly. That is to be fixed. I'm going to be having time this quarter to work on it. There's also another problem. Things can actually break in the back, and they break. I need to go and fix them. Now, every time that I fix something, or I release a new version of MOCI, which Pulse Actions uses, we're going to have things break because we don't have test coverage. And right now, if a person does not request an action, for a while, we won't know that there is a bug until then. Now, this is all just context of what this tool works like. In the future, in the next episodes or whenever, I will be working on making it more reliable by adding test coverage and preventing from getting ourselves into this situation. In any case, where we are right now, there is a bug, and that bug comes when we try to request jobs to be scheduled, and we actually schedule it through something. A lot of jobs we actually the Billboard jobs, we try not to schedule it through self-serve build API. We actually try to schedule it through Task Cluster, which will schedule Billboard jobs. There is a project called the Billboard Bridge. I have a module there in MOCI that deals with it, but the Billboard Bridge allows you to create Billboard jobs that are managed or monitored by Task Cluster tasks. So we have a graph, and a graph is composed of metadata, tasks, scopes, and now those tasks, they can have relationships between them. So you will have a build job and then a bunch of test jobs which would depend on the build job. So once we have a graph of what we want to be scheduled, we go and submit it. Unfortunately, in the last 2 weeks, we have been having some of them failing with a failure called task cluster res failure. Request payload must follow this schema. We should fix the issue that we don't validate what we want to post. Right now we don't. We should, and we will. But at the moment, let's try to figure out this issue. Now, after talking with Jonas, actually I'm gonna load one of these requests from Pulse Actions, just so you know what we're gonna be seeing. There are new jobs requested by a person that works with Instant Bird, and on that push they're adding jobs, and they requested matters like the Linux build, the debug build, the x64 build, the Mac builds, the XPC shell test jobs that run on the Mac builds, a bunch of things. So now MOCI goes and verifies that we have all the files required to schedule a test job. And by files I mean in this case the Thunderbird builds and the Thunderbird test files. So since it has all of these, we are ready to create a graph The graph has just a couple of scopes, and there are multiple tasks, a list of tasks. So there is one, and there are a couple of things that makes a task to be a billboard bridge capable task. There is a provisional called billboard bridge. There's a worker type called billboard bridge. And another thing that is important is create a payload that has some metadata that is important. A little bit about the push, a little bit, this is what is important. There is a billboard builder called TB WinNT52 Conbeta build. So the task running in task cluster will actually schedule a billboard job. And we have multiple tasks, one for every builder that was requested. And now we submit that task and we get a traceback. Now this traceback, unfortunately we don't do a very good job at dumping the actual issue. We'll have to fix that. And after some discussions, we had Jonas tell us that the owner property must be a valid email. Let's see what he means by the owner. So let's look for owner. Owner over here in the metadata, it says Aleph. But if we look at over here, inside of one of the tasks, inside of the metadata of one of the tasks, instead of the metadata of the whole graph, so if you look at the graph, it has 1, 2, and 3 main keys, one of them being metadata, and then each individual task actually has an owner field, and in this case it says Thunderbird build. Why is that? Now I'll show you. Let's load the push. In this push we have a push from a user called Thunderbird build. It was not actually done by a human. It's automation that uses instead of an email, it just pushes as a user rather than an email address. And task cluster doesn't like that. Task cluster expects an owner to be an email address. Why do we have this dissonance between the tasks and the metadata of the graph? In MossCI, a bit ago, we did a release where we try to add more metadata and try to put some of it on the tasks. For instance, if you think about it, the information that is on the graph, it actually talks about the person that requested the jobs to be added, while the metadata of the task contains information about the actual push instead of who requested adding jobs to. And this is where the problem comes from. We changed things, and because we didn't have unit tests, we started causing these issues. Now, what we have to figure out is, how do I go and fix this? We can do various things. We can fix pulse actions. We can fix MossCI, where the regression was introduced. Now I have to decide if I make a change in pulse actions, I'm going to be risking having to add a new version of MossCI, and the new version of MossCI, I could release it with just patching, going back in time and making small change after the regression was introduced, and make a very small change and a small package just to deal with that. But to be honest, I've lost a little bit of track of where we are with MossCI releases and what could have gone in, and because there is no complete coverage, we could be missing some features that I require now in pulse actions. So instead, what I'm gonna try to do is I'm going to patch temporarily pulse actions, and once I have a better plan, I'll record a video with the actual correct fix. And once we have deployed, we are close to the latest in Moz AI. Right now, because I had no time in the last 2 months to look at much of these, we were landing changes in Moz AI, but we were not updating pulse actions to be with the latest Moz AI. And because pulse action doesn't have unit tests, we couldn't actually determine if we were going to introduce any regressions. And unfortunately, now that I've given you this very long introduction, I think I might have to run upstairs because I'm being called for something important. So I'm going to stop it here. I'm going to make a second part. I'm just going to call this introduction to the problem or something like that. And I'll show you when the fun begins. Okay? So I'll be back with you shortly.